Hello, Algebra 2A, and welcome to day 1 of Lesson 48, where we are going to talk about how to simplify complex fractions. So we'll define what a complex fraction is, and then we'll look at two methods to simplify these complex fractions. And we use complex fractions in some upcoming lessons when we start to look at probability. So in probability, we're finding ratios, and then we might be seeing ratios within our ratios, which are exactly what complex fractions are. First, in our warm-up, there's a couple of things that we need to review. First, 2 over x is the blank of x over 2. That would be the reciprocal. In problem 2, divide and write the quotient in simplest form. So when we're working with complex fractions, we will be using division. And with fractions, remember dividing fractions, you don't divide at all. You actually multiply by the reciprocal. So here we're going to take 3/10 divided by 6/5. We're going to rewrite that as 3/10 times 5/6. Now it's important, if you have common factors in your numerator denominator, we can reduce those down. So those are both divisible by 5, becomes 2 and 1. 3 and 6 are both divisible by 3, so that becomes 2 and 1. Up in our numerator then, we just multiply across. We get 1 times 1, which is 1. 2 times 2, which is 4. So 3/10 divided by 6/5 is going to give us 1/4. So that is going to be our one of our strategies we can use to simplify complex fractions is we're going to use division. Now let's start talking about what complex fractions are and what they look like. A complex fraction is a fraction that contains one or more fractions in its numerator and denominator. So an example of a complex fraction could be a over b. So that within itself is a fraction, but then that could be just in the numerator. Then down your denominator, you could have another fraction, maybe c over d. So in our numerator and denominator, we have fractions. So we're going to talk about how do we simplify those fractions. In day 1, we'll look at just fractions that have numbers in them, and then in day 2, we'll look at when we get some variable terms in our fractions. So there's two methods that we can use to simplify complex fractions, and we'll use both of these methods so we can kind of see both of them, and then you can kind of decide how you would like to solve them. So method 1 is simplify as needed to write the numerator and denominator each as a single term, then divide. Only use when denominator is already a single term. So method 1, we can start to look at the numerator and denominator. So sometimes we might have in our numerator like a over b plus c over b, something like that. Well, we would want to add these two fractions together to make it a single term before we start to address that complex fraction. So that's one method is to add or subtract anything in the numerator denominator before we start to dive into that complex fraction. Method 2 is to multiply the numerator and denominator by the LCD of all the fraction in the complex fraction, then simplify. So method 2 is to do what's called clearing all denominators. And to clear denominators, you can multiply all your fractions by the LCD of all their denominators, and that will clear those denominators. So we're going to look at example 1 and example 2. So example 1, we can move right into the divide step. So we're going to look at that first, and then in example 2, we'll be able to practice both methods. So up above here, and we talked about complex fraction, you have a fraction within a fraction. And here we have a fraction within the numerator, and we have a fraction within the denominator. So I'm just going to kind of extend that fraction bar. We've got a 2/5 over 5/9. Anytime we just have a single term in the numerator, single term in the denominator, we are ready to start to address this complex fraction. One thing to keep in mind is the fraction bar that is separating the numerator and denominator of this complex fraction, that represents division. So really what we have here is we have 2/5 divided by 5/9. Now this is looking similar to our warm-up problem that we did up here. If I have 2/5 divided by 5/9, I can rewrite this as multiplication. So I could rewrite this as 2/5 times 9/5. Next, I would look at my numerator and denominator to see if there's any the common factors. So 2 and 5 have nothing in common. 9 and 5 have nothing in common. So I have nothing that I can start to simplify. So I'm ready to multiply across. So I multiply across my numerators, I get 18. Multiply across my denominators, I get 25. So all in all, that 2/5 over 5/9 simplifies to one fraction as 18/25. And it is going to be important to change complex fractions back to just a simple fraction, which is just a numerator and denominator, so no fractions within the fraction. So in example 1, we are looking at if you have a single fraction in your numerator, a single fraction in your denominator, you can use a divide fractions method. So that would just be using this part of method 1, just divide it. In example 1, part 2, we now are going to start to see we have a binomial, so 2 fractions in the numerator and then technically 2 fractions in the denominator. So we're going to look at both methods here. So I'm going to start by, in red here, we're going to look at method 1. So method 1 would be to take the numerator and denominator and add or subtract them to make one single fraction. So here I have a 3/5 plus 1/10. Well, looking at 5 and 10, I can make a common denominator of 10. So I'm going to make 6/10 plus 1/10. Okay. Down in my denominator, I've got a 4. Remember, there's a little 1 down there. I got a 4 over 1, and then I got a 3/8. Well, I can make both of these eighths. So I'm going to make a 32/8 plus 3/8. So far I've started to get common denominators to now simplify my numerator and denominator to one single fraction. So up in my numerator, I'm going to have 7/10. Down in my denominator, we're going to have 35/8. So we are now at the point where we were in example 1, the first problem, where I've now got a single fraction in my numerator and a single fraction in my denominator. I'm now ready to start my division. And remember, we're not dividing at all, so I'm going to take 7/10 times 8/35. And then I would look to start to simplify. So I've got a 7 and 35. Both of those are divisible by 7, so that becomes a 1, that becomes a 5. And then in my other fraction, I've got a 8, which becomes a 4, and then I've got a 10, which would become a 5. So there I've got my fractions ready to divide out, and now I'm left with 1 times 4 in my numerator, and I've got a 5 times 5 in my denominator. So I'm ready to multiply those across, and I'm going to get 4/25. So with the complex fractions, we want to end up getting it back down to a simple fraction with numerator and denominator. So we can do that using method 1, where we simplify our numerator to one fraction, simplify your denominator to one fraction, then divide. Now let's take a look at method 2. And in method 2, I'm going to do in blue down here. So method 2, I'm going to take my fraction, I'm going to rewrite it here. Method 2 looks at finding the LCM of all your denominators. So all your denominators would be 5, 10, and 8. 4 does have a denominator of 1, but that's not going to affect my LCM. So when I'm building my LCM, I'm looking for when I start multiplying out 5, 10, and 8, where are those going to meet? Well, if I start counting out 5, 10, 15, 20, start counting out 10, 20, and then start counting out 8s, they're all going to meet at 40. So I'm going to multiply my numerator and denominator by 40. Now, if I multiply a 40 in my numerator and I multiply it in my denominator, that's going to be multiplying it by 40/40ths, which is basically just multiplying it by 1, which isn't going to change the overall values. Now, here's what's unique that happens. I'm just going to take a look at this first fraction. So 40 multiplies 3/5. 40 is also going to multiply 1/10. But since 40 and 5 now have common factors, that's going to clear the denominator. So 40 becomes 8. 5 becomes a 1 because 40 and 5 both have a common factor of 5. So really all you're doing on this first problem is 8 times 3, which is 24. Secondly, 10 and 40 have a 4 in common. I'm sorry, a 10 in common. So that becomes a 1. That becomes a 4. So when I multiply 40 times 1/10, that becomes 4. So I'm just doing a little distributive. 40 times 3/5 is 24. 40 times 1/10 is going to be 4. 40 times 4 is 160. And then 40 times 3/8. Remember 8 and 40, since we found the LCM of 8, 5, and 10, 8 is going to have a common factor with 40, so that's going to become a 5. And then that's going to become a 1. So 5 times 3 is 15. So to recap, when I multiply everything by 40, 3/5 times 40 is 24. 1/10 times 40 is 4. 40 times 4 is 160. 40 times 3/8 is 15. Now we've got our numerator, which is 28. And we got our denominator, which is 175. Now we should get the same thing as up here. Well, a little bit of simplifying. We can divide by 7, which is going to give us 4/25. So 2 methods we can use to solve that. My preference is method 1, where we just take and get a fraction in the numerator and a fraction in the denominator. Then we can just use division of fractions, which is multiplying by the reciprocal. But you can also clear your denominators using that LCM. So you're now ready to work on Delta Math Lesson 48, Day 1. Thanks for joining, and we will see you next time.